This is problem number 17 in chapter 10. A study was conducted by U.S. Army to see if applying antiperspirant soldiers' feet for a few days would be a major hike and would help cut down the number of blisters soldiers had on their feet. An experiment for 3 nights before they went on a 13-mile hike. A group of 328 West Point cadets put on alcohol-based antiperspirant on their feet. A control group of 339 soldiers put on a similar but inactive preparation on their feet. On that day of the hike, the temperature reached 83 degrees Fahrenheit. At the end of the hike, 21 of the soldiers who had used antiperspirant and 48 of the control group had developed foot blisters. Let's see, we want to conduct a hypothesis test to see if the proportion of soldiers using antiperspirant was significantly lower than the control group. Alright, let's see, we have the antiperspirant group, let's call them. And then we have the control group. So let's start with these two groups. I like to label these things 1 and 2 so that anything that comes up here will use 1 and 2. So the group that used the antiperspirant was the 328 West Point cadets. So let's call that N. And for the first group, so that's N1, 328. And our N2, the control group, was 339 soldiers. Now, let's see how many people developed foot blisters. So at the end of the hike, 21% of the soldiers who had used antiperspirant developed foot blisters. So let's call this P, I think they call it P hat 1 is going to be 21%. And P hat 2 is going to be 48%. And conduct a study, this hypothesis test, to see if a proportion of soldiers using antiperspirant was significantly lower than the control group. So if we call this proportion of people who develop foot blisters, let's call this success of developing foot blisters. Let's say P is going to be our random variable P is going to be proportion who developed foot blisters. And so we want to know if the proportion of soldiers using antiperspirant was significantly lower. So let's say that's P1, significantly lower, that's a less than sign, than the P2. Alright, this is set up. This is clearly a proportion problem, and clearly there's 2 samples to deal with. This is a 2-prop, and the proportions are all z-tests, so we'll call it a 2-prop z-test. What else? What else is going to be important for us is, especially for using the calculator, is to figure out what our successes are. And if you know the relationship between the n, the p, and the x, it turns out that x over n is equal to p. And so if we're solving for x, we would multiply both sides by p or by n. So that's what we're going to do, is we're going to just find the percentage times this to get our x. Now we're going to have our calculators do this for us, and I can do that while we're on the screen of the 2-prop z-test. And we'll show you how to get that fixed up. Meanwhile, back to this idea that we're doing a hypothesis test. We begin our hypothesis test with a null and alternative hypotheses. And this time it's a proportion we're looking at the proportion, and it's a comparison between two proportions. And so this is a statement of our claim which has no condition of equality. So that would fall under the alternative hypothesis. So P1 less than P2, and then our null hypothesis would be the logical opposite, which will have a condition of equality. So P1 is bigger than or equal to P2. Again, you could have written that P1 is equal to P2 without any ill effects in our particular tests, because our claim is the alternative hypothesis. And because our claim is the alternative hypothesis, towards the end we're either going to be able to support the claim or not be able to support it. So if we're able to reject the null hypothesis, then we can actually support our claim. Okay, let's go to our calculators and pull up our 2-prop z-test. So let's hit stat, and 2-prop z-test is the 6th option in my calculator. So I'm going to go ahead and press 6, or you can scroll down towards it. And remember, the first thing that they ask for is the x. So x sub 1 over here is going to be the product of the proportion times n. So 21%, let's put that in decimal form, 0.21 times 328. Now, unfortunately, if you left your answer as 68.88, your calculator will not be happy about that. I'm just going to temporarily leave it like that just to show you what kind of error we're going to get. Our n is 328, and then our x2 is a product of 48% and 339. Again, this is a decimal, so we want to round this off appropriately, but I'll leave it like that again to set another example. Our n is 339. Now our claim, our alternative hypothesis rather, is a less than sign, so that's already selected. I'll keep that there. And then if I try to calculate this, I'll get an error. So error is something to do with a domain. So let's quit out of that error and go back to our test and actually fix our issues here. So back to number 6 for the 2-prop z-test. We have an issue with this being a decimal and not a whole number. So let's round this off to 69. And then looks like this disappeared. Let's call it 328. And then let's call this 163, rounding off again. And then 339. Okay, I think we're all set now. So enough fooling around. Let's go get our results. So we get a z and a p-value. Now, there's one thing I'm noticing about this p-value, and I'll discuss that in a minute. So meanwhile, the test statistic is a z-test. So you're going to get a z-value, it's negative 7.33, and it's very, very far away from 0, relatively speaking. So it's like about 7 standard deviations away from 0, which gives a p-value of 0. Now I want to be careful about this p-value. This p-value is not exactly 0. This is really close to 0, but it's not exactly 0. So a couple ways to denote that we have a really small number, but not exactly 0. You can write it with a 0 with a plus as an exponent, or you can write it as a 0.0 or 0.000. That just says it's really small. We also have a couple of other pieces of information. We have P1, they call it P1 hat, that's 21%. P2 hat is 48%. And then we have this P hat by itself. we have n1 and n2. So the p hat without the subscript is a combination of proportions. And so what they do is they gather the x's and the n's and make one big proportion out of that. So, alright, let's go back to, well actually let's write our x1 and x2, and I don't quite remember where that was, so let me go back to our test, because one nice thing about your calculator is that it keeps the same results from your last test that you ran. So we got 69 for this, and we got x2 is 163. Okay, not that important for our problem, but it's good to know what they are. Okay, so let's go back to our hypothesis test and finish it up. We have a p-value that's really small. So PV in this case is smaller than any alpha that we could imagine, so we're going to reject the null hypothesis. And our null hypothesis is opposite of the claim, so if we reject the null hypothesis, we are able to support the claim. So we can say our sample data supports the claim that, what was our claim again? Our claim is conduct a hypothesis test to see if the proportion of soldiers using antiperspirant was significantly lower than the control group. So we can just write it word for word. The claim that the proportion of soldiers using the antiperspirant was significantly lower than the control group. So again, if your claim is in the alternative hypothesis, then by attempting to reject the null hypothesis, you're actually in turn trying to support the claim, the alternative hypothesis. So by rejecting it, by rejecting the null, you're able to support the alternative, which is in this case our claim. Alright, I hope this problem works out, and I hope this helps your homework.